Ever wondered about the complexities of deploying containers in Docker? Well, you're not alone. Docker, a platform designed to simplify the process of application development, has revolutionized the way we create, deploy, and run applications. By bundling the application and all its dependencies into a neatly packaged container, Docker allows your work to run seamlessly in any environment. But what are these containers we speak of? Simply put, they're lightweight, standalone packages that contain everything an application needs to run. Think of them as your application's personal environment, with all the specific settings, libraries, and dependencies it requires. However, deploying these containers in Docker can sometimes feel like navigating a labyrinth. There are a myriad of challenges lurking around every corner, from managing multiple containers to network configuration and security issues. Over the next few minutes, a step-by-step guide on container deployment in Docker will be unraveled. Stay tuned. Before diving into the deployment, let's understand Docker containers. Imagine a shipping container. It's designed to be stacked, transported, and opened anywhere in the world. Docker containers operate on a similar principle, but instead of goods, they encapsulate software. Docker containers are lightweight, standalone, executable packages that include everything needed to run a piece of software. That includes the code, a runtime, system tools, system libraries, and settings. Essentially, a Docker container is an isolated environment where applications can run. Now, why do we prefer Docker containers over traditional virtual machines? Well, there are several reasons. Firstly, Docker containers are incredibly lightweight. Unlike virtual machines, which each need a full copy of an operating system to run, Docker containers share the host system's kernel, meaning they use less resources. This allows you to run more Docker containers on a given hardware combination than if you were using virtual machines. Secondly, Docker containers ensure consistency across multiple development and release cycles, addressing the "it works on my machine" problem. You can code locally, ship your work to another machine, and run it with the confidence that if it works on your machine, it'll work anywhere Docker is installed. Thirdly, Docker containers are great for microservices architecture. Each service, with its own environment and dependencies, can be encapsulated in a container. This leads to a clean, manageable architecture where each service can be updated, scaled, and deployed independently. And lastly, Docker containers are portable. You can build locally, deploy to the cloud, and run anywhere. This is a significant advantage in today's world of cloud services. In essence, Docker containers make it easy to pack, ship, and run applications, regardless of the environment. They're about consistency, performance, isolation, and scalability. They're about making developers' lives easier and their work more efficient. Now that we have a basic understanding of Docker containers, it's time to move on to the deployment process. Preparation is key for a smooth Docker deployment. Let's delve into the prerequisites for deploying a Docker container. Firstly, ensure Docker is installed on your machine. This might sound basic, but it's the foundation of everything we're doing here. Next, set up your Docker file. This file dictates the environment in which your application will run. It's like the recipe that Docker follows to build your container. So spend some time making sure it's configured correctly. Now let's talk about Docker images. These are read-only templates used to build containers. They're created from instructions in your Docker file. It's essential to understand how these images work, as they form the basis of your Docker containers. Remember, Docker is all about creating consistent, reproducible environments. By understanding and setting up these elements correctly, you're laying the groundwork for a successful deployment. With the prerequisites out of the way, it's time for the real action, deploying the container. Welcome to the heart of the process, deploying a Docker container. The first step in deploying a Docker container is to pull a Docker image. Think of an image as a blueprint of an application, containing all necessary components like libraries, dependencies, and the code itself. To pull an image, we use the docker pull command followed by the name of the image. If you're unsure of what image to pull, Docker Hub, the official Docker image repository, is a great place to start. Once we have our image, the next step is to run a Docker container from this image. This is where the magic happens. The docker run command is used to create a new container from an image. It's like bringing our blueprint to life. The docker run command is followed by the name of the image and optionally a tag if you want to specify a version. If no tag is specified, Docker will default to using the latest version. Now, you might wonder, how do we know if our container is running? Well, Docker has got us covered. The docker ps command is used to list all running containers. If everything went according to plan, you should see your container listed with some useful information such as its ID, the image it was created from, and its status. But what if you want to see all containers, not just the running ones? Simply use the docker psa command. The A flag stands for all. This command will show you all containers, both running and stopped. Now let's say you want to stop a running container. The docker stop command followed by the container ID or name will do the trick. To restart a stopped container, you can use the docker start command. And what about removing a container completely? The docker rme command is your friend here. Just remember, you need to stop a container before you can remove it. If you want to interact with a running container, you can use the docker exec command. This is especially useful if you want to debug or inspect the state of the container. The docker exec command is followed by the container ID and the command you want to execute. And finally, to save any changes you've made to a running container as a new image, you can use the docker commit command. This is a great way to create a customized image based on an existing one. So there you have it. We've covered the basics of deploying a Docker container, from pulling an image, running a container, verifying its status, interacting with it, and even committing changes. As you can see, Docker provides a rich set of commands that make the process of deploying and managing containers a breeze. And voila! The Docker container is now up and running. Even the best of us can run into issues during deployment. Let's dive into some of the common hiccups you might encounter during Docker deployment and how to troubleshoot them. Firstly, a common roadblock is the infamous Docker daemon not running error. This usually means that the Docker service isn't running on your system. To solve this, you can simply start the Docker service by using the command service docker start on Linux or by restarting Docker desktop on Windows or Mac. Next up, the no space left on device error. This comes up when Docker runs out of disk space. You can resolve this by cleaning up unused Docker resources with the docker system prune command. Another issue you might face is Docker image not found. This might be because the image doesn't exist, you've misspelled the image name, or you're not pointing to the right Docker registry. Double-check your spelling in the registry or pull the image manually to resolve this. Also, you may encounter network-related issues, such as Docker network is ambiguous. This typically happens when two or more networks share a similar name. The solution here is to specify the network ID instead of the network name in your Docker commands. Lastly, permission-denied errors are often due to insufficient user rights. To fix this, ensure that your user is part of the Docker group, or use sudo before your Docker commands. Remember, the Docker documentation and community are rich resources when you're stuck. Docker's logs and the verbose flag can provide more context around errors, and tools like Portainer can provide a more visual way to manage your Docker environment. In the world of software, troubleshooting is part of the journey. It's through resolving these issues that we truly understand the tools we're working with and become better developers. With these troubleshooting tips, we hope you'll be able to tackle any issues that come your way during deployment. Let's recap what we've learned today about Docker deployment. We started by understanding the very essence of Docker and its containers. These are lightweight, standalone, and executable software packages that include everything needed to run an application. We then dived into the intricacies of preparing for deployment, highlighting the importance of a well-structured Docker file and the role of Docker images in the process. We took a step-by-step journey through Docker deployment, showcasing how to pull an image from Docker Hub, create a container from that image, and finally, run the container. We also touched on the importance of managing and monitoring your containers for smooth operation. Lastly, we delved into troubleshooting common issues, emphasizing that a good understanding of Docker commands and logs can save you a lot of headache in the long run. Remember, practice makes perfect. So go ahead and try deploying a Docker container yourself.